So what's at risk, right? An attacker could introduce vulnerabilities into your code. An attacker could reveal your source code or secrets. An attacker could also direct an AI to do anything on your system it has access to do, right? And that could even mean setting up an SSH tunnel. And this is what's really terrifying about AI, right? And how is this happening today? This is happening from a new class of attacks we're calling prompt injection. An attacker hides a malicious instruction in different formats. And the core problem here is that LLMs are really bad at figuring out what's good input and what's bad input. Let's get started. How's everyone doing today? Let's go. But yeah, so I'll introduce myself. I'm Konstantino Sparakis. The name is as Greek as it gets. But yeah, I've been a software developer for over 10 years. Started my career off by studying over at Boston University. I did my master's and bachelor's in computer engineering. I studied theoretical cryptography and computer security. Got to work on cool projects like the XX network with David Chom, where we worked on building a quantum-resistant blockchain that also supported instant messaging, considering the adversary could be a nation state and making sure that messages are completely anonymous. Past that, I've worked in the crypto video game space and also in medtech, really places where security has never been optional. And quick question for all of y'all. What AI systems are you guys using today? Anybody here on ChatGPT Codex? If you could show hands. All right. Anybody on Claude Code? Showing some love to Claude. Anyone using Open Code? I figured. We have someone on Open Code. Awesome. Anyone using Perplexity? And I know we have some of the Perplexity engineers running around. And llamas. Anyone running their own LLMs? That's a fun one to get into. But and just out of curiosity as well, anyone here running MCP servers, using MCP servers? Kind of tough to use AI without MCP servers. But I'm showing this. I saw this in a tweet back in about 2021, 22. This is when Copilot first rolled out. And this is from a SendGrid engineer. They ended up posting in GitHub that AI is emitting secrets, right? So they were asking Copilot at the time, hey, give me a SendGrid API key. And it went ahead and actually did so. They later followed up on this. They said, well, it gave you keys that kind of looked like the real thing, but wasn't the real thing. But then some later research turns out that if you ask an LLM to give you API keys, roughly about 7% of the chance they will actually give you real API keys. And if you haven't rotated those keys, they're actually still valid today, right? And what really happens is these LLMs are trained on all public data. So people who hard code secrets in their code ended up leaking their secrets to LLMs and now the entire world, right? And what this kind of opens up the world to is this idea that security now is even that much more important, especially when we have machines that are becoming more intelligent, right? And this is a quote that comes from one of our engineers, Mike. He's actually over here with us. And he says, as the time an agent spends in the harness increases, the chance the agent will read every line it has access to and perform every action it has access to, or ability to perform, approaches 100%. And this is kind of that idea of if you have infinite monkeys typing on a typewriter, eventually one of them will type Romeo and Juliet word for word. And it's a really great mental framework for thinking about security when you're thinking about AI-driven systems, right? Because if you give it access to do something, even if you don't want it to do it, eventually it could potentially and will do it. So what's at risk, right? An attacker could introduce vulnerabilities into your code. An attacker could reveal your source code or secrets. An attacker could also direct an AI to do anything on your system it has access to do, right? And that could even mean setting up an SSH tunnel. And this is what's really terrifying about AI, right? And how is this happening today? This is happening from a new class of attacks we're calling prompt injection. An attacker hides a malicious instruction in different formats. And the core problem here is that LLMs are really bad at figuring out what's good input and what's bad input. And we've already seen a few of these in the wild. Just recently we had one where a GitHub issue had a instruction to leak that person's personal GitHub token. And anybody who just happened to tell their Claude code, hey, can you go investigate this repo for me? And it happened to be a really popular open source project. When they did so, their GitHub personal access token was leaked. There are also a whole bunch of MCP vulnerabilities that are kind of starting to pop up. This one's probably a little more due to the fact that we're still very new in the space, and a lot of MCP servers we're using are open source, ones that random devs have created, put on GitHub, and you're just kind of downloading and using them. So that, we're calling these MCP tool poisoning attacks. This is the idea that your MCP tool is injecting malicious intent into your prompts, right? We're also seeing a more advanced version of this called an MCP rug pull attack, where you download an MCP tool, it's acting completely normal, and at some point in time, whether it's via remote execution or like a timer, it turns around and actually starts doing malicious things, right? So you're trusting this tool, and all of a sudden it's doing things it's not supposed to be doing. And we're also seeing MCP supply chain attacks. And this is, if you see here, I have UVX on the screen. A lot of tutorials online, even if you ask ChatGPT, like, hey, can you help me set this MCP server up? Everyone uses this UVX command. It essentially downloads the latest repo from GitHub and runs it as a server on your machine locally. The issue with that is when you're using open source MCP servers that you don't know who's creating them, who's updating them, who's pushing code to it, you could be pulling something down that you haven't investigated and checked that it's actually secure. And the uncomfortable truth, right? So you want to develop with AI, but there still is no great solution for using, there's just no great security solution yet for protecting you against things like prompt injection and MCP rug pull attacks. So how do we defend against this, right? What's the right mental framework we need to take when we're thinking about, hey, I have an agent on my computer running and I want to make sure I'm doing it securely, right? And this is a concept that comes from the military. It's called defense in depth. My security people here will know this. This is like one of those OG things taught in every school. This was essentially brought over to the cybersecurity space by the NSA and NIST. But it's this idea that, let's say you're at war with someone. You're not going to build a wall to just keep them out. You're also going to build a moat. You're going to build another wall. You're probably going to put a watchtower, maybe some cameras, right? You want more and more layers of security because at least at that point you can slow the attacker down and possibly stop them along the way. And we need to kind of think about the same framework when we're thinking about using our AI agents. And so what does that look like today? We can put this together in a small diagram, right? So imagine we have a host machine, we have an agent process that could be Cloud Code, that could be Codex, it could be open code, and we're connected to the internet, we're talking to our LLM API, we're talking to our third-party services. Probably the first thing we want to do is tool grants. Easy thing to do, usually a config in JSON, where you essentially give access to tools on your computer, right, to the LLM. Another thing we can do, and really this is designed to be generalized, right? There's a whole host of research coming out. Structured queries is one that came out from Berkeley not too long ago. It's this idea that you can use XML tags around your input, and then any other input outside of it could be external input. We're hoping that our AI overlords like Claude are building this into their system so we don't have to think about it. But there are actually skills you can download and install to go ahead and do these things for you without thinking about it. And past that, we even have tools like Datadog's AI Guard. This one plugs into all your webhooks for your agent and essentially uses another LLM to judge every action you're about to take before it's taken to see if it's actually secure or not. So past this, let's say an attacker is able to get past all of these different little layers that we already have here. Now they could potentially have access to our host machine, right? So what if we have other sensitive files on there? What if we have things that we don't want to get leaked on there, right? So we probably want to put our agentic system inside of a Docker container. We want to make sure it has its own file system, so it's a little isolated. Turns out Docker systems are not actually that great at keeping agentic systems isolated. There is a really high escape velocity there. So we have to kind of go a little further in and make sure we're doing kernel level isolation. What does this actually look like? You can use something like gvisor as your Docker runtime. There's also a lot more other tools like NSJail from Google. That one will go ahead and lock your process down at the kernel level. There's other tools like, even coming from Alibaba, like Open Sandbox. and Apple has seatbelt profiles. So there's different approaches there, but the idea is we need to introduce a layer that really locks our LLM and kind of our agentic process down to a system that we can control and monitor. And past this, we're still connected to the internet, right? And this is where, if this wants to work, there we go. But yeah, so this is where proxy and gateway layer is kind of popping up. This is a host of new tools we're seeing. A lot of companies are working at this level. And essentially it's this idea that between our host machine and our containerized system, we're going to introduce tools like a network proxy, a credential proxy, and an MCP gateway, where every LLM request essentially gets processed here, right? And what happens there? So network proxy will go ahead and you can, make sure your LLM system is not accessing websites it's not supposed to. A credential proxy, it can work in different ways. It can make sure that every network request, if your secrets accidentally got put into the context window, make sure you blank them out. Make sure they're not getting actually to the LLM API. And MCP gateways, there's things like Docker's gateway. The idea there is, if we're running an enterprise, let's make sure all our MCPs are controlled. Let's make sure that all our engineers that are using our MCPs have the right permissions for every MCP call that we're trying to give it. And the last piece that we can add to this kind of little army that we're building here to defend ourselves is this idea of let's record all our conversations. Let's make sure we're saving everything so that with the proper tools and as everything improves, we can go back and actually inspect and audit everything, right? We should send all our logs maybe to a tool like Datadog. So what are the cons to this, right? Each layer tends to need a really detailed configuration, and we still have this idea of least privileged access for our AI agents becomes still really difficult for this, right? And we probably need to hire a team, maybe an engineer to manage all of this for us. And we're still only able to really defend against attacks that we know exist. So how do we get around this, right? And if we think about the 80-20 rule, what can we do for 20% of the effort and kind of get 80% of the results? That is where we introduce secrets, right? Your secrets are the key holding piece here. According to the Verizon data breach in 2025, about 88% of all breaches included credentials, right? So if we have really good secrets management practice, we can kind of avoid all these issues, right? Because at the end of the day, as long as our secrets are getting, if our secrets are rotated and are short-lived, then even if they get leaked, we're mostly protected, right? And that's where I happen to work at Doppler. We're a secrets management platform. We have 5 pillars of secure secrets management that I love to introduce everyone to. And this is how we think of and kind of have a mental framework for, how do you make sure you're managing your secrets properly at your org? So the first one is you need a single source of truth, right? People have secrets in their CI pipelines, people have secrets in their, AWS environments, GCP environments. Making sure you have it in one place gives you the ability to include, the second layer, which is governance, right? You want to be able to control who has access to what, when, and where, and who can edit things as well, right? Once you have everything in one place, now you need to be able to deliver your secrets to all your infrastructure, right? You need it in your local developers' environments. You need it over at, your CI pipelines. You need it in production as well. The next piece here, and this is the key piece that people miss, is you need to automate your rotation of secrets. And you also need to, things like dynamic credentials, where you generate short-lived credentials. This is a key piece. And the last piece here is visibility, having the ability to kind of go back and see who's accessed what, when, and where as well. So what does that look like? At Doppler, we've designed a product that is your single source of truth. We have this idea of secret sprawl, where you kind of go from your secrets being everywhere to you want them in one place, and then from there you can get them out to all the places you're using them. Doppler is project-based, and I'll give you guys a quick rundown and demo through our product, just so you guys get a taste of what a good secrets management platform looks like. And so Doppler is project-based. You can think of projects as microservices, databases. Each project breaks down into configurations. We separate them out into environments here. And we also have the ability to branch different environments, so you can kind of quickly create slightly different versions of your configurations. Doppler, and this is our secret panel here. You can see that we have different visibility types. You have the ability to reference secrets from other projects. So you can kind of build a hierarchy of secrets where if I update one secret in one place, it'll propagate out everywhere else. And we have automated syncs. This is that idea, again, right from the pillars. We want to be able to deliver our secrets everywhere. With automated syncs, you can plug right into your GitHub environments. You can plug right into AWS Secrets Manager if you want to stay on there. You can plug right into other tools like Vercel, Postman. We have quite a few integrations. The piece here, again, back to protecting ourselves from prompt injection attacks and protecting our secrets in those scenarios, automatic rotations, right? At Doppler, we have automated rotations, things like SendGrid API keys and database credentials. And we also have dynamic credentials. And you'll see here in this little video that I already have an AWS connection. I'm going in, I'm putting in my AWS user, I'm giving an IAM role. And the concept here is that every time I request my secrets, it's going to generate a fresh, short-lived credential to AWS. And here we have our CLI, really simple. I just run a Doppler setup, select my project, select my environments, and then I have access to my secrets. And we'll see here shortly, I have some fresh AWS credentials, right? So every time my users, my engineers are using AWS or even my service, those credentials are going to expire, right? So by the time a hacker gets those credentials, they don't even have access to my AWS account anymore. And the last piece here, Doppler integrates with seams like Datadog. So you're able to forward all your Doppler activity to a seam like Datadog, where you can then run anomaly analysis and make sure that if any behavior all of a sudden changes, you can react and ask your engineers, hey, something going on here? Are we potentially compromised? And the inevitable future, right? You guys are not going to stop using AI. Your competitors are not going to stop using AI, right? So you need to look at how do we defend ourselves while we use AI, and tools like Doppler and Datadog are here to help with that. Thank you guys.